This video is meant for Mrs. Rose's AB Calculus class on Rolle's theorem. Rolle's theorem says if f is continuous on an interval from a to b and differentiable on the interval from a to b, and if f of a equals f of b, where you have the same two y values, then there has to be at least one place, one x value, where the derivative equals 0. If you draw any 2 points that represent the endpoints of your interval, and you draw a continuous and differentiable function in between these two points, you will have to have at least one place where there is a horizontal tangent line. For example, you might have a quadratic. You're going to have a horizontal tangent line here. You might have something like a trig function that oscillates. You're going to have a horizontal tangent line here, here, and here. You might have a horizontal line that goes from one endpoint to the other, and in this case the slope is 0 for the entire interval. In any case, in any possibility, you might try to draw a continuous graph. You're going to have at least one x value where the derivative equals 0. The things that you need to be able to do are first, you need to be able to determine if you can apply Rolle's theorem to a function. To do that, you need to check if f of x is continuous and differentiable on that interval. So you need to look if there's going to be any discontinuities, like the denominator equals 0, or you need to look for things like corners, cusps, and vertical tangent lines, because that's going to be where your function is differentiable. Or rather, it's not going to be differentiable. The other thing you have to check is if your two y values are the same, if f of a equals f of b. If both of these things are okay, it is continuous, it is differentiable, and the two y values are the same, then you need to apply Rolle's theorem and determine the x values where the derivative equals 0. Alright, we're going to circle all functions that the Rolle's theorem can be applied to on the specified closed interval. If you've already been to class, you've been through this, but if you want to skip ahead, that's fine. Or pause here and try one on your own. Let's try one together. To see if you can apply Rolle's theorem, you need to first look to see if this is continuous. This is a quadratic. We know it's going to look something like this, and a quadratic is continuous everywhere. So we say yes, it is continuous on the interval. We also need to check to see if it's differentiable. A quadratic doesn't have a corner, a cusp, or a vertical tangent line, so it is differentiable on the interval. The last thing we need to check is to see if our y values are the same for the two x values on our interval. When you plug in 0, we're going to get 0 squared minus 0 equals 0. And when you plug in 2, you're going to get 4 minus 4, which equals 0. So that works out. We can apply Rolle's theorem to this. We won't be able to apply Rolle's theorem to g of x because you can't divide by 0, making this function discontinuous at 0. P of x, it is a quadratic, so we need to check to see if the two endpoints are the same, because it will be continuous and it will be differentiable. P of 1 is going to be 1 minus 5 plus 4, which is 0. And then P of 4 is going to be 16 minus 20 plus 4, which is 0. So yes, we can apply the Rolle's theorem to p of x. For our third function, tangent x, let's start with continuity. This function is really sine x over tangent over cosine x. And this is going to be undefined, or we're going to have an asymptote everywhere that the cosine of x equals 0, which on this interval is going to be at pi over 2. So tangent x, h of x, is not continuous at x equals pi over 2. Therefore, we cannot apply Rolle's theorem. Okay, so up here, I'm going to cross this off. Now let's look at cosine x. Cosine x is continuous everywhere and differentiable everywhere, so we know that we can say yes, continuous, yes. Now we need to check our two endpoints. When you plug in cosine of 0, we're going to get 1, and when you plug in cosine of 2 pi, we're also going to get 1. Those are the same, so this can be applied. We can apply Rolle's theorem. Our last function is q of x equals x squared minus 2x minus 3 over x plus 2. Because this function has a denominator, we know it's going to be discontinuous everywhere that the denominator equals 0, or at negative 2. However, that is not on the interval that was given to us, so q of x is continuous on the interval. It is also differentiable on the interval. The last thing we need to check is the y values at our two endpoints. When you plug in negative 1, we're going to get 1 plus 2 minus 3 over 1, which equals 0. And when you plug in 3, we're going to get 9 minus 6 minus 3 over 5, which is also 0. So we can apply Rolle's theorem. Now that we know which functions we can't apply Rolle's theorem to and which ones we can, we need to find all the critical values where the derivative equals 0. So go ahead and take the derivative of each of these four functions, f of x, p of x, m of x, and q of x, and find the values where the derivative equals 0. Have you done them all? Here are my solutions to f of x, p of x, and m of x. Here's my solution to q of x. If you have any additional questions, please feel free to come to Chem Morning or see me during class.